Good evening.
Good evening, sir.
So,
Yes, sir. You're
I'm ready, sir.
not see you. Your face is not there.
Okay. Wait.
Yes. Oh, wonderful. Very nice. Now you want to try your sharing. In this meantime, they're joining. We can try it if you want to try.
Yeah, I want to try because I'm more concerned about how it will.
Okay. He will share now. Just now, Chetu, can you share for him so he can try his.
Good evening, Sidhuji. This is Rubesh here.
Hi,
Yeah, let
Ramesh.
him share
How are
it.
you?
Yeah.
I'm good.
Let him
How
share
about
it
you?
first.
I'm good.
We want to get some experience of or good experience of what work you have done, today.
Let me try first my presentation whether it is working or not.
Don't tell us.
So
I think
sharing
we are
is
waiting.
enabled.
It will be real good experience or learning for agricultural engineers.
Sharing
We
is
want
enabled.
more.
Okay.
All right. I think he has shared. Can you check, Dr. Sidhu?
Yeah.
You got to share? Share screen. Can you press the share screen down?
Okay, let me check more. Where it is shared screen.
Down.
Down.
Participant. After participant.
After participant, I don't see.
You see start video mic. You see the screen?
Yeah, there is stop video and mic.
Participants.
Participants, yes.
Next share screen.
Invite, mute, raised hand. Attendees. Where is?
Setu, can you share screen for him?
I've enabled share screen, so I have to start sharing now.
Yeah, start share, please. Okay, now he shared. Now can you see? Dr. Sidhu, can you see now? After participants, can you see? After participants, do you get a share screen?
Okay.
I think let him double click on the screen so it becomes smaller. Probably he'll see that. Is it?
Okay.
No, somebody has done it. Explain it.
Sorry, I'm not that. There is a participants invite. I should double click my screen.
No, share screen. Setu,
There's a
can you help
green
him?
share screen button.
We can share the screenshot, sir.
Can you wait? One person talk, please. Parth, can you explain him?
So, sir, in the bottom of the screen, there is green button, share screen, with arrow pointing upward.
Arrow pointing upward.
Next to participants, there is a box.
Green button.
I can't see here. Problem is this.
You see Q&A. You see Q&A. Q&A written there.
Yeah. Q&A is there.
In between Q&A and participants.
Next to Q&A.
No, it is only that I can see only three things. Participants record on this computer and Q&A.
Setu, is it enabled or not?
So it is enabled. It is enabled.
Where he will see?
Besides question and answer, there is green screen, green button called share screen.
I think his screen mode is not maximized. Please tell him to maximize.
Yes, sir. Can you maximize full screen?
Share screen. Come, got it.
Yeah.
Click it, please.
Okay, so I clicked it. I think you can see my screen now.
No, you have to click on the screen what you have.
Okay.
You click on particular one and share right bottom, there will be a button called share that you must press. Then you will share. You see some screen now. Do you see some screen now?
Wait. Yes, I can see screen.
And the down share button is there. You see some share button?
It's coming.
Now
Yes,
it's
sir, it's
coming.
coming.
Oh, big clap too. Good, very good. Now you can run. Good, thank you.
Finally.
What,
Finally, sorry.
Okay, now I will tell you one more thing. On the top, you see here, stop share is there. Don't press now. You will see on the screen, stop share.
Yeah. Stop share.
Don't press now. So don't stop now. Whenever you want to stop it, you do that. Now you can
Sir,
stop again, start if you want. Yeah, please. Setu, go ahead.
yes, sir. I can stop his sir share, so need not to worry
no
about
problem.
that.
Okay, thank you.
So
Now we'll welcome all the people who are all there now.
now you can see.
Dr. Syed. Oh, Dr. Indramani. Good evening.
Good evening. Dr. Sidhu Saab, welcome.
Thank you, Dr. Saab.
Good evening, Indramaniji. This is Rupesh here.
Thank you. Good evening.
Is it working?
Yes.
I think. Okay, partner, Syed, how much time do I have? 40 minutes?
You try, you speak 30 minutes. If interesting for others, then you will get. I think you can. It depends on the topic, how you are talking, whether it's the audience, whether it's good, interesting. Normally it's about 30 minutes, but you can have 40, no problem, because today is special. Because you're going to talk about precision. And after your talk, I'm going to show how a particular example this has been done.
Yeah. I put
so
all
they
the
get a
stuff in my
solution.
presentation. Yeah,
because Dr. Singh also told me, why don't you show an example exactly how the electronics, everything can be used. So I think I take this particular session as an example to show them also. After his speech, and emphasize more on the stuff, real application. What I think you know what you're doing. So you go ahead with your speech. I think no problem at all. I think 30-40 minutes, but I think last no need to rush. I think put it might interesting. I think you are a very good speaker. I've seen you already. So go ahead. Don't worry about that. The question is
okay.
our objective is to see that people get interested to change, to get into electronic or control systems, or they have confidence. Yes, we can learn this. We can do that. I want the confidence to come. And as we get now, the most of training people want, most of the people remain. A lot of people, around more than 50%, 60%, they remain for the full session. But we also know the limitation. We cannot teach everything in this few hours. So we know it. But then this is only create awareness and some little knowledge. Like what we taught till now, all these 3 lectures, they will see from this example, your example, I will see some words, they will catch, yes, this is what we learned. That's objective. So I think you can go ahead, please.
Okay, so
not now.
Not now. Still, we have 5 minutes.
Yeah.
Still,
Dr. Indramani, please. You can introduce Dr. Sidhu. I think, or you want me to do that?
Dr. Sidhu needs no introduction.
You will do that.
Really, for the audience, the young scholars, young researchers, everybody knows Dr. Sidhu. He is my personal friend. I first met him in 1995 in a training, and I remember some jokes of Dr. Sidhu even at that time. So very, very humorous person, and very, he penetrates in the society among the audience, and he is friend of all, and personally my friend, and he actually was a professor at PAU, and then shifted to Borlag Institute for South Asia.
Okay. We'll wait till you introduce. Hey, Dr. Indramani, just wait for a while. You introduce afterwards. Dr. Syed Mehta, I see you. How are you? Good evening. Syed Mehta, I seen. We'll see who are all there. We have some time still.
So good evening, everyone. I also know Dr. Sidhu very well, and I am expecting him to deliver a very good talk today.
Definitely, definitely.
Doctor, thank you very much.
कैसे हैं?
बिल्कुल ठीक हूँ सर.
पंजाब में सब ठीक है?
हाँ, अभी तक तो relatively ठीक है सर.
अच्छा.
We should talk now in relative terms, no?
So we have to give more focus on institute management.
Yeah, absolutely. I'm going to talk on that also, like for a while.
Yeah. Because nowadays it is little bit shifted away from conservation agriculture.
Yeah.
Some of the machinery are being introduced, being promoted under that program also,
Yeah.
which are not fitting under conservation agriculture.
Dr. Mehta, good evening. This is Rubesh here.
Good evening. How are you, sir?
I'm good, sir. How are you too?
I'm also good. I am observing that we are having good presentation every day.
Yeah, that's Dr. Smile's work.
No.
And his pull.
Vijay,
And his pull.
Indramani, Vijay. I mean, there are a lot of people. There's a big team involved in getting speakers and organizing. Dr. Indramani is first person I think we have to thank for all these things what he's doing.
Yeah, thanks a lot. Yep, sure.
Good evening.
Syed, after my presentation, then there will be another session or?
No. I will show your presentation. Then I will start showing how it is done, what are the parts are done to explain them an example, live example.
Okay. Because I will leave it to you. Yeah.
Yeah. Then we may take in between questions also. When I'm presenting itself, the questions may come in both sides.
Okay.
One about your technology, what you're using. Second is about the electronics or controls. Both can come.
Right.
So it will be better that I explain. We'll decide it. We'll ask depending on the question. We'll select.
Right.
Thank you. Good evening, Narendra Shah. I see your face.
Yeah, I have unmuted myself so I can be heard 2 words. Hello and good evening to everybody. And we had huge rainfall this evening at Bangkok, and about almost an hour there was garaz baraz ke barish.
Oh. Professor Gajan Singh has just now joined.
Dr. Sir, good evening. Harminder Sidhu from Ludhiana.
सिद्धू सर नमस्ते, मुलाकात तो नहीं हुई बट हमारे स्टूडेंट को आपने एंटरटेन किया था, वेरी वेरी थैंक यू.
Thank you very much, sir. बहुत अच्छे लड़के थे. They were like बहुत ही बढ़िया, बहुत मजा आया. We enjoyed a lot working with them. No?
I will share one of the seminar report that they have done on IoT in agriculture. I will share with you.
Right, excellent.
हरमिंदर उनसे मैं करनाल में मिला ना क्लोजिंग में.
Right.
हाँ जी, Dr. Sir. You were there, yes. Yeah. दोनों बच्चे
Singh sir, one of them has written a very nice seminar report on IoT in agriculture. I will share this with you also.
Okay, thank you.
We'll wait for a couple of minutes. Some of our participants are coming. So just 2 minutes more.
It's fine, Syed. Oh, sure.
Yeah. Oh, Dr. Murthy, welcome. Vijay, you should show face to.
Yes. Hello, Dr. Syed. How are you?
Fine. Sidhu, I want you to both to meet. Vijay and Sidhu.
Hello, Dr. Sidhu. Good
Yeah,
evening.
you're all welcome to our place. Like, yeah.
Definitely.
Good evening, Sidhu sir. Vijay here.
Hi, Vijay. How are you?
Good sir. I'm.
You wanted to come to Ludhiana for last.
Yeah. Most welcome, sir. Everybody is most welcome to visit us.
Thank you, sir. Thank you, sir.
We are waiting for you to complete the guest house.
Already completed.
Oh, thank you.
Yes.
So, Dr. Sidhu, are you located in Ludhiana or where is Borlaug Institute located? I don't know.
Yeah, it is 20 kilometers, 18 kilometers to be very exact from Ludhiana Central,
Okay.
or you can say from Punjab Agriculture University.
Okay.
So it's only 15 to 20 minutes drive from the central place or from the city. Yeah.
I think we can start now. I think already. Dr. Indramani. Dr. Indramani, I think.
We're having one speaker, and from today onwards, we will try to have one speaker, more interaction, and more training. So this will be the Madhusar Pandit from today, and I request Dr. Syed. Although I said that Dr. Sidhu needs no introduction because he is known to all. He is known to all, and he has changed actually the face of Visa. He is pillar of Visa. So, and everybody who is visiting Ludhiana, he visits Visa as a pilgrimage, place of pilgrimage. Everybody goes, to see what he's doing. So I just request Dr. Syed to introduce Dr. Sidhu and request him to start his presentation.
Yeah. Thank you, Dr. Indramani.
Dr. Syed, please.
Thank you, Dr. Indramani. Dr. Sidhu, I met in Varanasi. I think he came and talked to me about 30 minutes. Then he invited me to Ludhiana once. I was there for about a day, almost less than a day. And I know Dr. Sidhu is station head of BISA, that's Borlaug Institute of South Asia. And he is doing excellent job in precision agriculture in conservative. I think he will introduce himself. I only know that he worked in PIU as a professor, then he chose to come to this. And I think he has done much more work. I know one more work also regarding the burning problem. Also, he was very active. And I also could a little bit help whether we work with him regarding that. I would request Dr. Sidhu first to introduce himself, introduce what is BISA, and then continue. Please, Dr. Sidhu.
Thank you, Syed, and thank you, ISA and the whole team to give me this opportunity to talk to you on this. My name is Harminder Singh Sidhu. I am Principal Research Engineer in Borlaug Institute for South Asia. BISA is a joint venture of ICR and CIMET, which is an international institute working in maize, wheat, and sustainable intensification, having a headquarter in Mexico. Before joining BISA or CIMET, I was a professor of agricultural engineering in the Department of Farm Power Machinery in PAU since 2009. And for the last 10-11 years, I'm working for CIMET in Borlaug Institute for South Asia. And in CIMET, my discipline is Sustainable Intensification Program, where we all together work on how we can sustainably intensify the system. So before starting my talk, let me say that, let me clarify that I am a farm machinery person. I'm not a soil water engineer. However, we did some work on water also. That is why today I will talk about conservation agriculture for sustainable intensification and smart irrigation, which we thought that we should work. So this is about my institute as well as myself. And my topic is smart irrigation for conservation agriculture, a way forward for sustainable intensification. So before moving forward, let us understand what is conservation agriculture. So conservation agriculture is having three principles: that minimum disturbance or no disturbance to soil, and soil cover with residue. And if you want to cover the soil with the residue, then you have to stop burning. And crop rotation. But said that we have to not do the monoculture, cereal. And then if we follow these three principles, then there are three benefits: enhanced productivity, richer resources, and climate adaptation. So I will talk during my presentation that how the conservation agriculture or sustainable intensification program also helpful in adapting climatic variability or climatic change. Or so if we follow this conservation agriculture, if we follow the key principles that influences the soil, physical, chemical, and biochemical process, in turns modify the water and nutrient dynamics in the soil. For example, let me share one very interesting thing with you all, that the crown root initiation in wheat under the tilled condition, in the normal condition, is come on around 20 to 25 days when the first irrigation is there. But in case of conservation agriculture, when you are under zero tillage and keeping the residue in the surface, so we have noticed that the CRI stage is on 15 to 18 days. So this is very interesting for the wheat breeders also. So that means if we are influencing the soil physical, chemical, and biochemical process, so that means we need to modify our water and nutrient dynamics in the soil also. And we need a new set of recommendations when we follow the conservation agriculture principle, which implies we need new machines and techniques. For that, the capacity building of all the stakeholders, starting from the scientists, farmers, manufacturers, students, are very, very important when you talk about conservation agriculture. Basically, what we want to do is we need to produce more from less. That means less of water, less of energy, and for more people, that too on sustainable basis. So we want to produce more food with the less of water, less of nutrient, less of tillage, less of energy for more people, that too on the sustainable basis. So why we want to do this conservation agriculture things here? Basically, there are some challenges. Agriculture challenges, there are some man-made challenges, I will say, and there are some nature-made challenges. The result is very evident. The result is we are continued depletion of water, soil health is deteriorating, greenhouse gas emission or global warming things, and yield gap and low farmers' profit. So I don't want to go to each bullet because there are some challenges on this side where are man-made and there are nature-made. So when we combine all these challenges and we end up with these bullets, and in case of health, we always talk One Health. It is not only the soil health, it is for the human health also, it is for the animal health also, right? So for example, residue burning, like not only impacting the soil health, but it also impacts the human health as well as animal health also. So our challenge is enhancing the farmer's income with sustaining natural resources under emerging climate risk. So this is our challenge. So I will start with residue burning. As Syed said, that we are working on residue burning. So this was for the last 2 years, if you noticed that this was the burning issue in India, especially in the North India. But I will see this issue in the light of the current situation. So if there is air pollution from the open agriculture burning, then cardiovascular and chronic pulmonary disease will increase, and it will aggravate the severity of the COVID situation or COVID symptoms which we are facing right now in the world. And it will significantly increase the mortality rate if there are the situations because of the air pollution, if you are suffering from some diseases because of the poor air quality. So what we need to do is, can we make the residue burning a relic of the past so that to avoid the worst pandemic in near terms? So that means what we are doing for the past 2 years, it was all related to the present situation also. We can always see or link it with the present situation, and we have to be very careful in future also. So most of the people know about the machine. This is a happy seeder which can seed directly. It is a conservation agriculture machine which can seed directly in the presence of residue in a single pass. and its cost is around $2,000, or you can say 1.4 lakhs around. And how it works, when we harvest rice, and then there is a sufficient residual moisture on the ground, and when we harvest rice, and the moisture is there, and now this field is ready for me for seeding my next crop. So now I don't need to do any tillage. I don't need to do any burning. I can come with my seeder, that is a happy seeder, and seed my next crop. So this video, it is a 1-minute video which shows that we don't need any turnover period. We can harvest our crop and seed our next crop right way. So this, now the field, this is the crop after 10 days. The wheat is emerging from the residue, and you can see it is a single pass technology which requires only a 1 pass, or if I go very precisely, for 1 acre you need only 4 to 5 liters of diesel if you are having a happy seeder and your tractor. So this is the cheapest option available till today. See, what we want to do is, everybody is like, if you see, we call it as a technology with the multiple wins. If we see the agenda of our Prime Minister, he want to improve soil health. You are adding residue back to the soil, it is improving soil health. More crop per drop. You don't need to even give the preceding irrigation. In this situation, we are saving almost 20% water. Lower cost and higher profits, doubling farmers' income. So it is a single pass technology which can save a lot of not only energy, time, but also money also. It reduces the GHG emission, less weeds. Less weeds means less load of chemicals on the ground. So, and the last is reduced weather risk. The weather risk includes either it is more rain, either it is a less rain, either it is a terminal heat, either it is a more wind at the time of harvest. That means less lodging. So this technology helps in mitigating all the weather risk. That is why I talked about one of my slides about the climatic adaptation. So let me show you some pictures of last year. So this is Ludhiana on 23rd January. On this side, so this is a field after tillage. And there was 72 mm rain on 23rd January 2019. And we visited the field after 24 hours. So you can see the situation. Here the water is there, still there. And here the wheat was under zero tillage after maize. In this field, even you can walk. So that means, so if it is more rain, it handles. This is another story. There is another big rain event in Ludhiana on 5th or 6th February night, 84 mm rain in one day. The wheat and conservation tillage on this side, and wheat in the residue or under conservation agriculture is on this side. Another picture. So this is wheat after tillage in February, and this is a wheat in the residue. So that means, so we can even, there are many instances. This year it was at the time of harvest wheat. There was a bad weather, still bad weather. Today in Ludhiana it is cloudy. So that means this technology, conservation agriculture principles, can handle the adversity of the weather. So people generally ask me, if we don't till, if we keep the residue on the surface, how many years we can do this? So this is a data from a long-term trial from an ICR institute where our colleagues and the CSSRI people in Karnal working. So we are doing, they are using this technology for since 2009. So it is a 11-year yield data, which shows either you are getting same yield or more yield using conservation agriculture. So this is I don't want to go into the data more because I want to finish between the given time. So this is one evidence. This is coming from the ICR Agriculture Technology Application Research Institute, Zone 1. This is for the last year. 76% farmers said that they get more yield with this technology. 95% farmers said that there was less weed, and 58% said that there was less lodging. So that means it is a technology with the multiple wins. So that is why all the institute, ICR, Punjab Agriculture University, other universities, all are promoting this in a big way, including CIMET and VISA, because we should promote a technology or a method which is feasible, which is economical, which is sustainable, and which is scalable. And I'm happy to share, I have the data for Punjab, that we have more than 15,000 machines working in the field in last 2 years. So this is another evidence about this. So this is in August 2019. This is a publication in the Science, which was covered by more than 40 national and international papers, field on fires, alternative to crop residue burning. And this also supports what we are saying. Currently, 50,000 machines are working in the region, in Punjab, I'll say, because I don't have the exact data for Haryana. And for the 2 years, and government gave, and with the support of ICR and others, I had a big program on 1,200 crores on residue burning. But my question, when there are 15,000 machines, and what we were struggling, we want to see where these 15,000 machines are working. We want to get the data. So this is a map for Ludhiana. The yellow dots, which we are seeing on the map, this is the fields under Happy Seeder, or with this technology, conservation agriculture. So this is a very, very challenging for the monitoring people also, for the department also. Even you don't know where the machine is working. I discussed this issue that I want to monitor each and every machine. And Dr. I requested Dr. Syed to support me in this. And what we did is, so this is a small, we call it as a happy tracker, Syed, and it is a real-time monitor for machinery use and its movement. And I think after my presentation, Syed will explain you more on this. But we tried this, and because we want to monitor each and every machine working in the, so that this is also one way of automating monitoring. So otherwise, it is very difficult to go and follow the farmers and go to each and every field to take the GPS and other thing. What this small device is doing, it is a real-time tracking activities of CRM and good estimate of area covered, because if you know the width of the machine, and it gives you a good estimate. And earlier we were doing ground truthing by going to like 500 fields, 1,000 fields. so that we can give that data to our remote sensing team, so that they can match and do some good estimates. So let me go quickly through it is a real-time tracking, but the good part is, so this distinguish between the parked and on road and in operation field, right? Sending location of the machine every 2 minutes and the speed of operation, and you can even see the live battery status, and there is a live dashboard on your mobile, and all the data is stored on the servers, and there is a 2-day internal battery life, and easy to install on any machine, and only requirement is you need a 12-volt connection or a charging system on your tractor or on your machine. So this is a snapshot of a happy tracker. It is giving the GPS locations, latitude, longitude, and other thing, even the speed. And this is even if you go to the records, you can see the date wise where it was moving. So this is one thing which was very interesting for us. This year we tested on few machines. Next year we are going to use it on the large numbers, right? Or presently on this part we are working on a project which is called Harit, and it is harnessing the power of agricultural residue through innovative technology. So people think that the residue is a problem, and we think it is a very powerful thing. We should harness its power. Now, the next part, we thought, can we marry conservation agriculture with the smart irrigation using subsurface drip irrigation? We call it as a CA plus, conservation agriculture plus. The basic purpose of this exercise was, if you see an agricultural engineer, the biggest problem, the micro irrigation, drip irrigation, and other things are very good in the controlled environment and very easy to handle. But if you go for the field crops, it is very difficult. The only one hindrance I always listen from the people, that you have to take all the pipes out of the field when you want to do any agriculture operation, either it is spraying, seeding, and then you have to redo it before every irrigation. So that is the tedious. We thought, because we are not tilling the field and we are keeping residue on the surface, why not to put these lines below the surface, and we should irrigate, or we should give the water where it is required. So the one hypothesis was the minimum surface evaporation, it will improve water use efficiency. And as an agricultural engineer or farm machinery person, for me, that my machines can run on the surface, easy mechanical operation, because it is all buried, and effective fertigation. And we never thought that if you give a subsurface irrigation to your crops, the weed population is very, very less. It is like an added advantage, because you never give irrigation to the top 5 centimeters. It is always in the root zone. And more drip life. Normally, I ask the micro irrigation companies that what is the life of a drip pipe lying on the surface. They say 5 to 6 years, and our trials are more than 8 years now, and they are saying it will go like maybe 10, 12 years if it is buried. So then another exciting thing was, like, can we automate it? Right? So why we monitor the subsurface soil water metric potential and give the water as and when required, and that too directly in the root zone. So then this was where to put, because at the time of seeding it is 5 centimeters, and we need more water close to 5 centimeters. When the root develops, we need more water in the root zone. And what should be the lateral spacing? What should be the drip spacing? What should be the drip discharge? And these were all the scientific questions. Can we use it for the field crops? So we started with this. But the only challenge was how to lay the drip at a desired depth. And we consulted all the companies, both the companies, even Netafim and others, to look for a machine which can put a drip tape at the desired depth. But then we designed a small machine, which is a 2-row, which can be operated with a 50 horsepower tractor. You can put the drip tape at the desired depth. So from the back, from here, you can increase or decrease the depth spacing. So this is our trial. Now we are, for the last 5-6 years, we are growing successfully crops like maize and wheat with the subsurface drip, and even rice and wheat with the subsurface drip. So the results are here. I don't want to go because of the time constraint into the detail, but very interestingly, you can save a lot of water. Like in maize wheat system, it is amazing because last year, the people from Asian Maize Conference, which held in Ludhiana, they visited us, and we shared with them that you can grow 15 tons grain per hectare with 29 centimeter or 30 centimeter water in a year. 15 ton grain, that is like almost more than 8 ton maize and more than 6 ton wheat with the very, very little water. And for the rice wheat, even 13 ton grains with the 17 to 80 centimeter of water. So you can see the 6.3 ton. So this is the graph which we are seeing is, it is the average of 3-year data which we presented to the Asian Maize Conference people. So 15 ton grains with the 28 or 29 centimeter water. Then even Dr. Vijendra Singh with the team from many teams. Yeah. So they visited us and we showed all these trials to them. And the one issue when we started working on this line, we were not knowing, even the literature was not very, very supportive, or we Googled everything. We are giving water and the nutrient in the root zone. How much and how many times? That is how we can optimize the rate and timing. So then we did experiments for calculating that optimizing the rate and timing of fertigation, because in this there are some data for the surface drip, but when you are giving directly in the root zone, then we have to establish that optimizing the rate and timings for fertigation. And then we did some like different yield and uptake with the different system where you're giving flood irrigation, where you're giving subsurface drip irrigation. This is all stuff in different projects, because I got one project where I got money from UK government and in collaboration with DBT, where we did all this study. But the interesting part for an agricultural engineer is that now the breeders are interested to evaluate their breeding material under this environment. They are saying that every genotype, either it is a maize or wheat genotype, it has an interaction with the environment as well as management. We call it as a GEM trial. The genotype into environment into management. Now we are evaluating different genotypes of maize as well as wheat under the contrasting management practices. So this is a one very good sign. People are seeing a possibility. Some genotypes are very good in maize wheat system, and the same genotype is not doing good in rice wheat system. Earlier, and even some genotypes are very good in subsurface drip, and other are good in zero tillage with the flood irrigation. So now we are working on this direction also. So then we established a precision nutrition platform where the motivation was automation. As I told you earlier, that I'm not a soil water engineer, but like we basically our team learned by making mistakes. So we try to bring different puzzles together. How my water meter can talk to my controller, how my wall can talk to my controller, how my sensor in the field can talk to my controller, and how my fertigation machine can talk to my controller, and marrying everything and sending data back to my computer on this. So as Syed was telling that at this point I was struggling, and then we set up a precision fertigation platform, and with the fully automated, even filtration unit is fully automated, but our challenges were not ending, because we took 2 years data, what you're seeing here on this screen, but it was an all wired connection. From the field, the wires were coming to the controller, to my, and it worked very well for 2 years. But one fine evening, there was a electric, the rain, then this all electric lightning, and it damaged everything, all the cards and all things. And then luckily I met Syed in Varanasi. and I like, we sat after the session, we sat on a table, and I told him that I'm struggling with this, and then can we do something where I don't need wires to communicate with my system. And so this is all the data which is coming to our system. And but my problem was, I don't want that the wire should come from the field to my system. And this was a struggle. And I want to continuously monitor the subsoil metric potential with the reliable wireless switching facility. You mean like because the reliable means it should be, the switching facility should be very, very reliable. In the water saving games with the micro irrigation, there is one challenge, because you always give water in small packets, right? If you miss one packet or 2 packets, it will damage the whole game. So that is why I was looking for a reliable wireless switching, and I want to that I can it should be automated. And earlier system was also the wired thing also, but with a remote communication. Even the condition like now, that if I am in curfew or in the lockdown, I can monitor my field sitting on my in my home or from a remote place. Then we were also very much interested in modeling studies on subsurface water and nutrient movement below the surface. And there was like one girl from PAU. She's Arpana Bajpai. She's doing her PhD with us yesterday in PAU on this topic. And what next? We are still in the smart irrigation. We still have to try the micronutrients through this system. We call it as a intravenous injection for the crops, and the application of even weedicide. the soil-borne weedicide, can we control weeds also with this? So this is what we were doing. We were calibrating new sensors, new techniques, and even we imported some dye from Australia also to know what is happening below the soil, where the water is going, and how much and what is the movement. I think from this PhD study, we will be very clear on that part also. And here, I think then for the last almost 1.5 years, with the help of Syed, and I always give problems to Syed. I always tell that this is my problem. I want to do this, and let us see how good. Now we are using the problem in the automated subsurface drip irrigation. Even in the surface drip irrigation is still in India we don't have the reliable sensors, right? On this side, this is a tensiometer from Aerometer, with a very renowned company. This is very good. Under maybe like up to 40 kilopascals. As soon as you go above 40 kilopascal, it fails. And on this side, this is MPS6, and this is very good in when you are your soil water potential is high, 40, 50, 60, but it is very bad when it is low. So because my purpose of giving this talk is like, I'm very selfish on that part also. Said it's not training part is one part, but I'm speaking to the people on who are online on Facebook and through this Zoom, that if they can help me as well as Syed and all our team to have a reliable sensor which is affordable for the farmer, and because I want to make a case for a 5-acre farmers, then 5-acre farmer doesn't have to do anything for his irrigation as well as fertigation. So on this side, which you are seeing, it is a sensor device which we are using. We put this MPS6 sensors in the ground, and this sensor device can work in the radius of, I think it's more than 200 meter diameters, and now we are using this instead of wired section. Then this sensor is connected to this device, and this device is connected to my controller through this actuator device, which tells my controller that which valve and which should be open, and my water meter is also connected to this. So now all the devices are linked through Wi-Fi, and it is working, I should say, reasonably good. But when the internet fails, then my server keeps on sending me emails that your internet is not working, your internet is not working. Again, this is one limitation. And this is what we are doing, what we are trying to do, that marrying conservation agriculture principles with the precision water and nutrient application using subsurface drip. That is why we call it as a, this is a data sheet which is coming from my actuator and the sensor device. You can see it is a dashboard, and you can even see on your mobile also, on your laptop also, even it is telling which valve is working, which play is working. And so for me, this is my last slide. I think I'm within the time. It's Syed, it is 36 minutes only. And
no problem. Yeah.
This is my last slide. A technology cannot be an innovation if you don't add a local adaptation and social inclusivity and access to that technology, and you are getting feedback for that technology, and the people are willing to buy or pay for that technology. And if you add all these factors to your technology, then it really becomes innovation. And I'm ending my talk with a quote from Bernard Shaw, that you see things and you say why, but I dream things that never were, and I say why not. Thank you very much.
Thank you. Thank you, Dr. Sidhu. It was an excellent talk. I think all of us understood what you wanted to convey. And
Thank you. Thank you, Dr. Sidhu.
Yeah, you can give your comments first, then I will start. Dr. Indramani?
Yeah, it was
what?
You know, this technology part, little so far covered. No, so how can you connect what you have done at Visa, what Dr. Sidhu showed, little more detail about the technical part.
Correct. So I think this is a good opportunity for in the last 3 days we had probably about 2 hours of session of trying to understand electronics, and we had a short introduction about microcontrollers in 3 sessions. That's almost about 2 hours of session. This is very short. And we actually, when we started this program also, we know very well that the electronics or embedded system is a very vast subject, and we cannot teach them in 10 classes or 20 classes. I know it very well, but we have to start somewhere. So why I started, I will explain to you. There are 3 layers I see. One is the top level management people I see. Could be in industry or it could be in department who really sanction funds and do that, whatever, that position. Middle level management also there. Last is the people who really work on the line. In agriculture engineering, all these 3 are almost without knowledge of the technology. For example, today, Dr. Sidhu told Wi-Fi is using 200 meters reliably. He's using for 1.5 years almost, and he's having problem because internet connection is not there. That was his problem. Okay, now there are many other technologies available. The question is, I want the top management, middle management to learn what is the difference between gallbladder and kidney. Okay, simple differences. We must understand what are the differences between these two and which I should go for, so they can ask questions. They can ask questions to all the people. Oh, this is there. I heard somewhere. You tell me why. That much knowledge is enough for the top level management and middle level right now. Middle level can go a little bit more, but the down level, they have to learn, because I would tell you now, I am an agriculture engineer. I have never studied electronics. And if you ask me now, Dr. Syed, you're working so long so you can design. It is wrong, because I can tell you exactly, it took me 2 months only to learn electronics and work with electronics in Bangkok. That was a challenge. That was a task given to me by my professors, because I wanted not to work on solar energy. I wanted to switch over to control systems. So when I could do it, what I want to say is the youngsters can also learn. So we will make this training program, whatever it is, to the extent that you are convinced, yes, technology is easy for me to understand. That is all. That is success for me. We will again, ISE, we will work together to find out a method for really people who want to learn in detail. So that we will assign a particular time and group. But this one is meant for all the 3, top level, middle management, and low level. So bear with us for this, the training. I will try to go slow after the training session, but I would like you people to, after every topic, I'll stop. You raise your hands, and no problem at all, raise your hands and ask me. Then I can explain at least basics for you. Now, with that introduction, I come back to Dr. Sidhu. Now, Dr. Sidhu, what he is doing, how a system works, we will see. Like, for example, he told a sense, I will explain a sensor device he has got, and he has got actuator device. A sensor device is battery operated with 3 cells, pencil cells. It is in the center of the field. There are no wires coming there. He has connected 4 of the soil moisture sensors to that, 4 of the sensors. So we actually made a system we tried out with capacitive other type. I could not do it because I didn't have any support of the people, others who are required. Now, the data is sent by wireless to his main place where he has a filtration system and pump system. There we have actuated device, which actually will control will start a particular valve or start a pump. And there is also a tank where you can measure the water height. Now, when you want to start, he will sit in his home probably and key in from his mobile, he can check, I want so many kPa, minus 40 kPa when it comes, I want the pump to start. This is, he can do it from his cell phone. The limits he can set. When he sets a limit, it takes care of automatically. So from the sensor, it goes to actuator, both of them connected to internet domain and comes to server and to his cell phone. From there he controls. So we require some connectivity. And the sensor device, I have given around 15 minutes of data to come. I think 5 minutes data is about 1.5 months it will go. We can make reliably up to 3 months to 6 months with the battery operated sensors. This is working. Actually, when he asked, I never worked on this in the field. We selected Wi-Fi, and this was actually 2 boards only I made, very short time. And I will go through this process completely, explain you what are all required in this. For example, what is a sensor device? What is inside there? Okay, how it communicates to actuator device, actuator what it does. Then you're telling me about something like it goes to go to internet domain. So how the data is going to internet domain? In the computer, what program I have to write in that computer, internet domain, so I can see the data. And what all feature I must have into the internet domain. For example, if internet is not there, connectivity is not there, you have to get an email, you have to go and check. Option is, even if you put a GSM, which is a cell phone, if it's not working, you have to get an email. And this, I know Dr. Sidhu didn't allow me to in the night or day, Saturday or Sunday, for him doesn't matter. He will sit at home, he will call me, and he says, this particular one must be done. And I think there is something of this, which I find an agriculture engineer has the insight. He says, if it doesn't work, I must get an email or SMS to me immediately saying that it is down because it's far away from his place. So he can do something, ask somebody to go and check up the connectivity. So this all I will explain. That is the session going to be now. In between, till I prepare, I allow 1 or 2 questions to ask on the whatever Dr. Sidhu's talk. I see 2 questions. Technical about what the electronics, everything. After my talk, we'll talk about. Dr. Murthy, Santi Murthy, you have 1 question. I'll allow, please, can you ask that?
Sure. Thank you so much, Dr. Syed. Thank you so much, Dr. Sidhu, for the wonderful talk. I had 2 or 3 things that I had questions about. The first question is, so when you do this kind of yield maximization through the drip irrigation and the conservation agriculture and the drip irrigation, what is the impact of the sustainable intensification practices on the micronutrient quality of the crop? Has that been studied or is that being studied? That's my first question. The second question is, I was reading some reports that the burning of residues was connected with how the crop season moved from basically being ending in October to later part of the November. And that was the reason why a lot of these because farmers have to burn the crops, and how far is that responsible? And then finally, the third question is, you talked about soil sensors and that you need reliable soil sensors. I was wondering if you could put like few performance criteria out so that we can know, for example, when you say what is the reliability, what kind of reliable performance, how long and things are you expecting, what is the price target and stuff like that. If you can please take a shot at that, that would be great.
Thank you, Dr. Murthy. The first thing is micronutrient analysis. Till date, what we did is even in breeding trial also, or other trials also, we worked mainly on the nitrogen uptake, not on the other micronutrients, right? We have a data on the nitrogen uptake, which is better under these scenario. So we have not worked on the other micronutrients. But mainly the nitrogen level. And the second question you are asking, that the residue burning is like the pushing the transplanting date back is responsible. I don't think that is the case, because now we have varieties which can well matured between the given time, and we have a technology which requires a zero turnover period, like what I showed you. You harvest your rice and you seed your next crop, you're paid. And then coming to the reliability of the sensors, I tried. I went to every place or every person, either like the people sitting in Calcutta. There is a firm who's supplying sensors, and I visited them personally. My problem is I don't want to. I don't need a reliable sensor for measuring the things. No, I need a reliable sensor for switching with the switching property, right? For example, we were using tensiometer. We used tensiometer for more than 4 years, but tensiometer is very good. Like when the tension is around 40 or 45 kPa. As soon as one fine morning you go to your field and you see that your tensiometer is failed, and it is like there is an air bubble in the tensiometer, right? So that is my problem, right? Second thing, then we move to this MPS6 sensors, which I showed in my presentation. They are very good in the higher range, but they are not very good in the lower range. So I need, because for example, if you work in the rice wheat system, as per the literature or the data available with us, we need to irrigate the rice as soon as the soil matter potential is around 15 in the subsoil, right? But we need to irrigate maize when the soil matter potential is maybe 50 kilopascals. So I need a range, but with a reliable thing. I hope I answer your questions.
Thank you so much. The reason I was asking that is because we could actually think of developing our own sensors for our conditions.
Yeah.
Thank you.
Yeah, we will take that questions next later on when I complete it. I think we'll take. I want to show you first what is the device functionality and how it was designed. We'll go through each step of the design. So this I go through the manual what I sent them. So from there some features we'll see. So a sensor device, each sensor device you can connect 4 of the soil moisture sensor, which they are using, which is called MPS, matrix potential sensor, which is actually a measurement of dielectric. The sensors I will cover also afterwards. After a short while, I will cover the sensors which are available, which work we can do also. Now, I also try to make capacitive sensor a little bit, but we didn't have time, like I told you. But you can connect, if you make perfectly the sensor and trials, everything, somebody does it, you can connect 3 with this. You can have 1 tank water level sensor. You want to measure water pumps to the tank before it goes to the different valves connected. That you can measure. There we have used a really low cost ultrasonic sensor. Now I will test it's accurate enough for agricultural purposes. Okay, we'll come back to that sensor also explain you. So very low cost, you can attach one of the ultrasonic sensors to this. Then he also wanted to measure the humidity, temperature, and atmospheric pressure. Okay, this actually his assistants or his lab people wanted CO2 measurement also. But this I was doing first time. We can connect CO2 with this. CO2 sensors are cost-wise. You can get for 3,000 rupees and up to 40,000 rupees. So you have to have the correct sensors selected. So I told we will do that in second stage. Now, these are all present. Now you can also, it can have some 3 digital inputs you can to have to this. Now, sensor devices with operated works, it should work for several months. I think practically, when you get the data, probably it can work up to 6 months. We can make this to work. So cells to be changed 6 months means 1 season. After 1 season, you change the cell. There is no problem. This cost is also very less. You can use a normal double TAA cells of 3 cells. Now, how often the data must go to the server, everything can be all done afterwards for you. You only have to put a sensor device. Suppose you put a sensor device. Tomorrow, you decide, I want to change the program there. Okay, something I want to modify there. You can do it remotely. That was a requirement also. Because we cannot go there physically, pull out the sensor. I want to change the program. So this is an important feature incorporated in this. So sitting in my room, I can write the program, put on the internet. It will actually find out the sensor and the particular sensor device. It will update the program for that also. So that is not used only once we tried it, but the facility was foreseen. Sorry. Now, this same board I made, because he told me when I saw the configuration, he requires sensor board and actuator board. Sensor board will be in the field. Actuator board will be near the pumping station, where the valves are there, where the pump is there, where the drip irrigation system is there. So I made the same board. I just put 5 relays more for actuator. That's all. So very easy to use. You can replace also. In problem comes, something happens to him. This you can put one wire there, jumper, configure it to sensor device, or configure it to actuator device. So it becomes easier. No need to have 2 products for making it. It can be configured. It doesn't cost much, nothing is. So now I will see through this particular one, the board. We will see as first while. The board size, everything I will show you. Just I will show you detail, we'll see slowly. For example, these are all the ones, I think mouse you can see, they are the relays. 1, 0, 1, 2, 3, 4, 4 relays. Here you can see 0, 1, 2, 3, 4 connected relays. You can connect 220 volts directly here. So you can connect, it's a potential free. You can connect anything you want. So these 2 will be shorted if particular output should go high. When this relay will go high, when you program particular sensor, from particular sensor, you're getting a data that is, let's say, minus 23 kPa, then I have to start this particular motor. So the sensor will send it to the cloud, and cloud will check what settings he has done, because the settings are stored in the cloud. And from there, it will send instruction to this actuated device to turn on that particular relay. Once it's given the instruction, his automatic system, what he has got, will take care of scheduling, how much nutrient to put, how much water to put. That is not done by this device. This is only, like you told, replacing the wires. But we can make a similar here also. You can add a very little features. This itself can directly actuate also scheduler. As this is what really need today. Today the need, I will come back to the farm. This we can do it as a very low cost. Is a huge need for semi-automatic drip irrigation automation systems. I will explain you other parts. Most of the parts we have seen in our lecture. When I say the word, it will click you. For example, this particular one we see here, this is the, yesterday I explained you SOC, system on chip. I explained microcontroller slide 1. We'll come back to that today also. Then I explained Arduino. Then I explained system on chip, which has got a Wi-Fi. I think most of you can recall Wi-Fi word I told. So this is the Wi-Fi antenna. This particular one, is this a controller? There is almost everything. Okay. So this does all the job. This is main. Now for that, first time when I want to program, I can program with this connector. That is UART. Serial connector. Yesterday we thought about UART, long distance it can go. That you can connect here. Now you see here display we didn't see till now. This is a display to show locally for you. When you go there, you want to diagnose what is happening. So it can display something here. It is a graphic display. Now we come back here. We also studied For last one, about multiplexes. Multiplexes we studied. Multiplexes, multiple inputs. Suppose I got 10 sensors, 4 sensors, temperature sensor. How will I connect to my computer? So here is a multiplexer chip. Because these 1, 2, 3, 4, these 4 are this MP6 soil moisture sensor. Okay. This soil moisture sensor, MP6 soil moisture sensor, is connected these 4. I will read one after another only, because this particular SoC, system on chip controller, it has got only one analog input channel, only one serial input channel. It has got only one UART. So this can be done sensors. We don't worry about right now how it is connected. There is a multiplexer for this. So the multiplexer joins all the 4. From here, I can select which one I want to select. This one, this one, this one, this one. So when I will show you the program later on, you'll go and scan automatically one after another. Okay. The sensor particular one has got intelligence. This particular sensor, what is using intelligence, it has got a temperature sensor inside, built inside the moisture sensor. So it gives both. So the data is taken, put there. Now we have got another one here as an operational amplifier. I will not explain now why. We studied about also operational amplifiers or linear valves, linear gain you will have. Transistors have non-linear property, whereas operational amplifier. Now we come to here. Here is one IC is there. This is actually expander. See, for example, this particular device, SOIC, you see, it has got very less wires can come out. 1, 2, 3, about 6 here, this side, 6 this side. But remember, our objective is to control 5 relays, and to read 4 sensors. And also we told about it has to also have digital inputs, which is defined. And it must also read capacitive sensors. Okay, even though it's not being used, it was tried for. So all these things where the input-output lines this fellow does not have so much. So we use an expander, which is called I2C expander. That is called I2C bus. So we use an I2C expander here, which will give 16. This becomes extended to 16 of the input-output. So input expander I2C it is working. Now here I've done this is a box sensor for temperature and humidity. Temperature humidity sensors are quite accurate enough, and there are very many low-cost sensors are available. We will discuss in sensor section, supposed to be tomorrow. This is using again I2C, SDA, SCL. So this particular temperature sensor will be very close to this box only. That is inside the box only. But you have to be careful to put the temperature humidity sensor inside the box, because these relays can generate heat. We don't want the heat to affect. So we have to put on the periphery a bit carefully. That has been done. I will show you that how. Now, this is the input. I told digital inputs you want to have it. So this battery will be connected. Battery is in a small plastic enclosure. Battery is connected. Now we come back to the features. Like I told you, the device supports FOTA. That's a firmware can be uploaded directly from the server. For that, the program we are writing here in this. How do you write this program? This is very simple. This we use, which is very popular, easy to understand, Arduino IDE. That's called Arduino. We'll come back to that. We'll see that also later on. That is using C++ program. The advantage of this particular one is to write to display, all the programs are there already. Somebody made for you, given the library is free for you. So you need not worry about this library. This also library you're getting in the internet domain, free for you. There are a lot of free web sources. Somebody was talking about from IIT Kharagpur saying the source software cost and must be free. Most of them open source. Open source like our from Bank of Friend talked about. It's all open source available to you. So the whole board designing and developing time, if you ask me, designing time it took me for about 2 days, and the whole board to get ready, program everything up running around 8 days. Okay, so total within 2 weeks he got the board. including board manufactured by somebody came to me, everything. So that is the time it takes. We'll come back to next one. This is a requirement. So what our requirement? Again, I repeat again here. The requirement was to measure the moisture from the 4 sensors coming inside for him. The sensor will be and transmit the data through the Wi-Fi. That is his requirement. And that is called sensor device. Actuator device, he will not use this. If you want, he can use it, but he will not use the actuator device. He may use only the ultrasonic sensor, which is here. This here is ultrasonic sensor. I will show you the sensor also, which one was connected. So height can be, water tank height can be measured in the actuator. In the actuator side, you want to measure the water tank, then you can link with this, because there is a pump has to be started to pump in the water tank, and when the full it comes to a certain level, you must shut off the pump. That is also done as a setting from your mobile phone on the cloud setting. You can set this particular ultrasonic sensor height, how much it measures, from this many centimeters only, then it must stop. So we have to put in some hysteresis inside. I mean, those who know about control. So this is also can be done. This is the idea of this. So this perfectly works. So this is one. We'll come back to second one is we require on the internet domain, he told. So now when you go to internet, so I must know about what is the possibility of internet. What is the possibility of internet? Which are all the options available, like a manager? I must know. First, I must know multiple users can be using. There is a different users, managed users are there, and we'll come back. Masters are there. Settings will be there. Here he does settings. Okay, for example, here the MPS sensor, what is the limit value? When to start the particular pump, when this limit is exceeded. So this is how the settings he is doing. The value is shown already, data coming. I will show you live also this data as of now. After this, I will show you live. I can just log in and show you live in the internet. The data is coming. What is measuring? You can see temperature, humidity, the pressure, atmospheric pressure, and it dew point it gives. So this is not complicated. Now what I want agriculture engineer to do, to understand these features, and he has to coordinate with 3 people now. Okay, number 1, he must select which components are required. So he will ask a hardware person, I want to connect temperature sensor, I want to connect this, so he must know that. He must tell him. Hardware person will make a PCB design. He will design PCB. Then he has to find an embedded software programmer who knows C, C++. Then request him to write the program for this particular one, Wi-Fi module here, whatever the local controller. Then third person here to catch who knows about internet domain, web server programming. There are also multiple choices are there. For example, this data is using HTTP protocol. We are sending through HTTP protocol. We can send through data through TCP protocol. We can send through MQTT protocol. We will understand all the details. We have to know it so we can tell them, I want this protocol to be used. So engineers must understand only this is good for this purpose. Every protocol has its own limitation, its own advantage. That much if you know only, projects will come fast. Why I'm telling is, otherwise you go and tell one person, he does not know about web, because electronic engineers does not know this also. Remember, most of the guys skip the subject, some of the chapters. This is normal, we know that. So electronic guy who is good in hardware, he will never know about the software. Okay, but it is easy for an engineer to understand and do it. I will show you each one step. I think we'll take this time another few minutes, because this I will create interest. Give me a few minutes to change the next slide. You could not see my screen. I'll share again. Sorry. Can you give me share, please?
I want one.
Okay. Okay. Now I explain you. This is the first box I sent to them. This is the first, they're not using this particular box. I sent him first, when he told a sample in 2 weeks, I sent him this. I didn't go. I only had a talk with him for about half an hour in Varanasi. I understood what he wanted. I manufactured one box and sent him. About 2-3 weeks it took. Then when I visited there, I saw the expression, what he told me, what is the requirement, I could not grasp properly. So it is some other required. So then we made second. But I want to way to show this box to you is, for example, here down you can see AM2320. This is one of the temperature humidity sensor. This is so small. This is the sensor. Okay, but this is big. There is a small hole, and that is a sensor from humidity, temperature, very, very small. You require a 3 mm hole. Okay, from inside the sensor is mounted, and this box is, when vertically you place it, this is the bottom side. So water will not go, nothing will go. It's not open space kept. And you have the connectors which are going. The box is, enclosure must be IP65. So it's on the rake. Winter, summer, we will take care of the box enclosure, how it should be. This is how the first one worked. You can see in this display how it shows agri sensor application. It shows you can give displays of temperature, humidity, everything for. This is the second version which I gave him. So you can see the sensor device, actuator device. Both are same actually. You can remove this connector and put there. It will work. Inside you have to open and make one shorting. Here you will see different sensors are given here. I will show you each one of them. One of the MPS sensor, he sent it to me. The rest of them we give some sensors. This is the new PCB looks like, which you saw already without relays much in the first. And this we have seen already in the PCB. Now, this I think, I don't know how much you will not understand, 100% I know that, but still I'm telling, because you must know the process. This is called schematics. Okay. Schematics is pictorially drawing what is the content inside. You will not understand, but please bear with me. This is the Wi-Fi module. We draw it. This is the EEPROM. Yesterday I told about EEPROM, which can store, so data can be logged inside. I can log the data for him with the EEPROM I provided if he wants for almost a year. The data can be, whatever temperature, whatever soil moisture he's logging can be put into this. Now this is, for example, the I2C expander IC, and this also got a real-time clock. So in case internet connectivity is not there or real-time, you can scan and store the data. So this is how the first to be drawn here. Here we see the MOSFET. I just show you. It looks funny to see what is the MOSFET here. Here is the drawing of relay. So all we learned, there's a components will be present in this schematic. This you cannot draw. I don't think you can draw. I'm not looking at you can draw this unless you have experience. You go for it. I don't expect agriculture engineer to come to this level unless he is really very keen, but he can do it. Question of a couple of months seriously working, he can come to that level. Doesn't want, no problem. He must be able to tell an engineer to do it. Next, make the layout. So PCB layout designing is also another skill required. So at least we must know agricultural environment or what are precautions to be taken. For example, Dr. Sidhu told about lightning effect. He had lightning, everything burnt out. So that is a very important thing. We have to take care of it. So we have to tell them it's outside in the field. There will be fluctuations. There will be noise coming inside, water. So all these things must be taken care of. So this is how the PCB looks like, who have not seen this before. And now I will show you about the sensors available. The soil moisture is a big problem actually. Everybody, I know, I will tell you technique at least, what are the techniques available and what we have to do. So not available, we don't do any work, nothing, we will not get anything. We need a team of people seriously to work on it. And not to bluff, say, that's what I ask everybody, does it work? Because I don't want to hurt them, they are all experts, but then it's not in the field. I have not seen in one field being used. Only I have seen in Ludhiana being used. I will tell you the techniques now. Capacitive. It's like you touch your key, everything. This is to measure the capacitance. You can measure through capacitance accurate enough. But you need around, see this, frequency what we have to use. That we have to see. We need very high, somewhere about 10 megahertz 5, 7, 8 megahertz we have to have. And this has to be properly do. You will get certain range only soil moisture. You cannot get the full range like Dr. Sidhu told. I agree. But this will give, this capacity measurement will give you at least for a certain type of soil. People ask me, different soil, different this one will be different. Doesn't matter. We can calibrate it. We have nothing right now. So we can start with this. Second one is this capacity. Different are there. One is with the rod. You can use 2 rods and the capacitance measure. Otherwise, it is PCB, printed circuit board. Yeah. Okay. PCB, so you can use it. Next type of sensor is called TDR, time domain reflection. Okay, what it does is he sends a high frequency signal from one of the rods. When it reaches here, there will be time delay and high frequency. This also goes in very high, where it is used, TDR. Is electrical wires, telephone wires, they lay underground, they want to find out where it breaks. When it breaks, it will be like this, 2 wires broken, then you will find the time domain reflection. So these, some of the people I know in India import 50 pieces or something like that, or more, but it's not working. So nobody has worked on it. They tried, one day it works, one day it doesn't work. So, but I feel CDR is a good area. Again, seriously, if somebody thinks and works, calibration, you cannot have universal calibration. It's not possible. But at least certain type of soil, once you can calibrate in the fields, no problem at all. See, we are not going so accurate like Dr. Sidhu's application, where he's talking about precise application. Directly, he's 20 centimeters down the ground, he's talking about, and 40 centimeters under the ground. If I'm right, Dr. Sidhu, is that correct? 20 centimeters for wheat, he's giving water down, and 40 centimeters for the paddy. So I'll come back to the paddy solution again. What we talked about, what is solution available. No need for soil moisture sensor, the depth sensor will do for the paddy cultivation. Now, this MP6, what do you call? This is from one of the US professors says, he has done it actually, left the university and started. This is the advantage of this, the calibration is a big problem. So the MP6 is being calibrated. He gives guarantee plus minus 20% accuracy is there in most of the conditions, plus minus 20%. Most of the people in India, when I ask about soil moisture, Dr. Sidhu will say he talks in kPa, kilopascals, because it's a negative surface, negative tension you're measuring. So minus 12 kPa, minus 20 kPa. Whereas other people when present, I listen to them as percentage, soil moisture 10%, 20%, which is not correct. Actually, the correct, because the people don't know, they think hobby stuff, they take it. So this dielectric metric potential sensors also can be manufactured in India, or somebody can talk with the people and some how they make, because it's from the university came out. Calibration is expensive for them actually. When I studied a lot of articles about them, but this IIT or some people, electronic people must be involved, agriculture must be involved. So then I think can come to a solution. Ultrasonic depth sensor. This is actually can measure up to close to almost 2 meters. 4 meters you can go up to 4 meters, 4.5 meters, 5 meters you can go this. This is a low cost one and just filled up with the glue on the outside. So water will not go. So now, for example, paddy, when you want to measure, paddy actually you don't need to flood the water, especially when you put the irrigated paddy, not irrigated paddy. Water need not stand on the top of the surface, not required. There will be enough work done. I can show that enough work is done. I remember last year also when I was the NABARD for one of the meetings, IIT Kharagpur was there, the same thing was discussed. So you can actually go down, water depletion, not on the surface, you can go down, but how much it goes down, you have to measure it. Then you have to irrigate again. Otherwise, the crop will die. So how to measure it? There are works done, make a small pit there, and water level will be there. You have to measure the water level correctly. This is an ideal. This is excellently ideal, but it will work only for irrigated paddy like that. So this is only, I think if you ask the cost, maybe few hundred rupees is the cost. Only good, but this works. There are water resistance or waterproof sensors also available, but you don't need it because if the water is completely gone inside only, it will not work. But water dries up, it works. So this is not getting damaged. That is enough for us because you don't put this into the water. You put at a height of 30 centimeters or something above the water. So this will work. Now, I will show you this is a tracker device which Dr. Sidhu which I sent, very short notice he asked. This is a tracker device. This is a device which this is the GPS, for example, and this is the chip with the GSM, and this is where you insert the SIM card. It has got a flash memory, storage memory, everything. This is the antenna, and this you can connect a 24 volts battery also. So up to 40 volts battery it can connect. It has got a lot of features. Backside there's a battery inside, so it can charge the battery, everything. This was done quickly for him because he has for short time to get. So I see a lot of applications. You want to put a GSM communication. This is not a problem at all today. It's not a problem. It's not a big thing to come and I will present a paper and saying GSM I'm using to transfer data. That is not technology today. Children are doing almost. So I think agriculture engineers, we must learn these technologies are easy to. That's my objective for the whole thing. So this is how for example, the tracker, how it looks. Now, what we saw till now, I will recall back again. So we talk about sensor, actuator, what are the components we used, okay, electronic components we require, and we talked about microcomputer we require what features. Then we talked about we need somebody who can design this circuit diagram, who can make the PCB. Then we told somebody must write a program on that. Or that's some program. So I told C program you can write. Like I told you, I'm going to show the program what is written for this. One part is over, PCB designing, designing everything required. Second part I will show you. You could see my screen now? Can somebody, yeah, thank you. Now you have, for example, here, this is an Arduino directly. This particular program, which is running in beta form, is this program. This is in C.
No.
I think.
Sir, there is another screen.
It is the previous screen.
Yeah.
I'm sorry. Yes. Now?
Now better. Now it's okay.
Now it's got. It's okay. Now it's okay?
Yeah, now it's okay.
Okay, thank you. So this is actually I'm running from the Arduino screen to show you how complex it is. The idea is not, you will not understand the lines, I know that, but see that at least how complex, how many lines the program I have written to do this job. Okay, these are all libraries given here. I think slightly big I can make it, and you can see you will not understand much, but I will tell you RF client, Wi-Fi client, it will automatically connect to Wi-Fi. These programs are given by somebody, and web server, but I'm not using web server in this to do it. What is web server? If you don't understand, don't worry about it. And I'm using SSD display. The display driver programs are given by somebody else. So I'm including these programs by include command. So you see almost BME 280. I told you the sensor for humidity temperature. I'm not writing program. Somebody has written already and given me. I just include here. And there is some way of using it, calling the program. That's all over. So now you see the program line when I come here, you'll go on writing. You have to define, like, for example, you have to know host. The web server also required, because sensor module must send the data to the remote server. So remote server IP address you will define. So these are all technical, Torah. I think when we cover that part, we'll come, or we'll have a special session for all these things to teach. I want to teach because knowledge must be there for you. What type of server you have to hire also is the knowledge required for you. Linux server you will have, Windows server, what is the drawback you will have. Because agricultural applications, you cannot afford to have very expensive server. It's too expensive server hosting. People say, you take Amazon, whatever, you cannot afford to pay monthly 15,000-20,000 rupees. You cannot hear? If somebody want to speak, you have to speak. Robesh?
Yeah.
Yeah, tell me. No, not for me. Okay. Now I'll show you this is a program. For example, this is the main loop, what comes here. And this is the main loop. I'll show the program. This is, for example, relay string. It will make a string for the relay to send, which relay must activate out of the 5 relays. And this particular one, what is the type it is actuator or is it sensor? Because same program is used for both. So I can put this actuator program or same program will do both. So I do not worry about it. Same board can be used. Then this is the display the values of the soil moisture sensor on the display we have. This is display BME, display the temperature, humidity, and atmospheric pressure. This much lines only I have to write. I did not write so many lines. Only itna line over. That's all over. And this is process data. So what I'm getting data to send, I want to send the data to the remote server. Which all data I have to add? That I have. You will not understand much. Which all I have to add? Humidity string. I'm adding humidity. I'm adding temperature. Okay, temperature is added. Then humidity is added. Pressure is added. And relay, what the relay position is added. Now this data is sent. See, actuator also, when he receives a command from server, you turn on relay number 4. Then the actuator must send back to the server saying, yes, I have turned on number 4. Then only the confirmation is there. Okay. So this is works on two-way communication. I say you turn on, he has to report to me saying that you have turned on. Otherwise, we will not know whether it really worked or not. And next, I'll see you battery voltage. Because battery is going down, battery I must send. Because battery operator sends us. So I should give the indication to the server saying that RAR is going to drain in 2 days, 3 days, you go and change. So that information required. Then you come to the capacitance. This is for the capacitance reading program. Read capacitance. The program is only this much line. It will read the capacitance. And this is for measurement of BME. I mean, which is temperature, humidity, and atmospheric pressure measurement program. This is ultrasonic. The height measurement, how to measure, only this much program. And this scan matrix will go and scan all the Pulsar sensors, one after another, and get the information. And this is, I told you we are using I2C expander. That means input output we don't have in this because the device is very small. We have expanded another 16 because 5 relays required, 3 inputs required. So 5 and 3 already 8 required. And this particular main controller, we don't have so many pins. So we expand that. For that, the program is given here, this much program. So when you see total, I will not go for all. This much is the program is not very big, very big. But I think because it looks all new to somebody, we are astonished. That's the reason children, when you go to YouTube everywhere, see children all play with so-called Arduino and everything because of the power of the library. And it's very good for agriculture engineers, I'm telling you. We don't require that much technology to understand. For example, I did not understand how a complete protocol of I2C from each device to device changes. For example, I connect a real-time clock, or I connect an IO expander, or I connect a temperature sensor. This all already somebody wrote for me. So I need not understand. I have to only plug and play. So this part is the second part, what I explained. We also must see the third part to understand. That is from server side. Okay. I will again here stop and tell you 2 parts we have covered. One part is what is the features required in our field device that we will write. How many relays we require, how many sensors we require. Then somebody will design that particular one taking care of the precautions and what is the requirements. We will do that. And we ask somebody to design the PCB and then give the PCB and procure the components, solder it. That person, 99% will not do for you the programming. Okay. In my experience of 40 years in India, 30 years at least, nobody is doing both, very rarely. Now you had catch somebody to write this program like this for that particular board, sensor board, actual board to work. But that doesn't stop there. Now it must go to the domain, it must go to the remote server on cloud. So I will show you the example for that program now to you. You could see that? You could see that now screen? Okay. Okay, thank you. Now, this is actually a PHP script. PHP is a programming language on the server, main server. What this program does, this program is the main program. Every sensor device or every actual device will send the data. Whatever data is transmitted, internet domain will come to this program. This program, what it has to do now, Very first you get the data, it must store the data first somewhere. Normally we do. So we make a database, these are all background work, and somebody stores the data. Afterwards, we must take some action if required. Okay, some action to be required. So that action also has to be taken here. So for example, one of the action is to send the email to the guy if the data has not come. That action has to be taken also. So here you see here, all these parameters, this is very simple. PHP, when somebody knows about C or something, they can really learn very fast. It's only the fear we have. Any programming language is same, I challenge. Whether it's PHP, Java, whatever you call, structure is same. Only question of, unfortunately, even today, the programmers are all cut and paste only. They don't understand the basics. And because 90% people don't write programs, only 10% write. 90% only cut and paste and application. That's acceptable. There's no problem in it. But I think we should know what we are going to get. If agriculture engineer cannot write this program, no problem. But you must know what you want to get the data and how you want to store. That you must tell the person. I want to access this data fast. This data I want in dashboard. This data I want to do it. Otherwise, that person doesn't not know what you want. What is the importance of each parameter? So here is the different parameters. It says automatically, it takes it, each one of them, capacitance, everything it takes. You can, if you read all in English only, simple, you'll understand. KPA written there, okay. Battery volt, here for example, written there, battery volt, BME, temperature, BME, humidity, it takes the data. From the HTTP protocol, what the sensor is sending, this fellow is decoding here. He's taking into one of the variable names. Simple programming it is. After taking it, he will store it, insert, see here, come on, insert. So he puts the data, whatever comes as it is, first into the database table, one table he puts. After putting in the table, now he will try to find out, we have one more last data we keep actually. What is, because dashboard will show you what is the last received data. Any dashboard when I want to see it. So let's say I have got a farm with 50 sensors. I want to know the 50 sensors, how many working or not working, which are giving alarm situation. This I want to see on my dashboard. So I can take some action. If you want detail on this, I'll click on them and get the details. So you must define on the dashboard what is required. And we will show the dashboard what is required. In the next, we'll show you. I will show live one data coming at least from there. Now we will see here, when it comes to here, this is the different sensor value. Here you see the height, last known height it shows. This is from ultrasonic sensor height. So these are all the different 4 sensors, MPS 0, 1, 2, 3, 4 sensors you have. So data is inserts and goes away. Now, there's one more program working. If the data doesn't come within half an hour, it must fire a message to the person in charge and saying that your internet is not working in the field. Communication some problem. That could be communication problem or it could be sensor problem, but you know data is not coming. But we also have methods to find out which problem it is. That also we can find out. There is no problem in that. Okay, now I show you new screen. This is actually alert process PHP. This is alert program. So this program actually, I will not detail go through it. This program will actually find the data has come within the time on. This is running always in the web server. In the cloud, it's running automatically. Continuously will be running, checking data has come. Last data when it came. Okay, right now last data came. He will wait, go and see another 15 minutes data has not come. There's a problem. So I must send an email to him. That email address, everything you can define and put. These are all blocked here. Anyway, you can send the email automatically. What is the content, everything. It will go to sure. So what we have to do is we need somebody to write these programs also. We need somebody to. We have to find out somebody who can write these programs. I would here stop for a while and ask people who doesn't understand anybody of. I would first prefer from the people in the panelists to raise and give me some opinion how this was and what we should do. Anybody want to talk from the panelists? Give their opinion. Please, Ravesh.
So if I understood from you the programming, and definitely there are certain preferences of programming, but as an agricultural engineer, I think he can definitely write down very accurately the inputs, the customer expectations and output in maybe a simple Word document, which becomes like if he does that very well and he takes to the
I got your point. I got your point. See, the
then
question is,
and the
no,
programming then
will
will
not,
automatically become repetitive later on,
no,
for
no,
him
no,
to.
no. No, first of all, I must know the possibilities. What are the possibilities I have to understand? Then only I can write. If I don't know the possibilities, I will give all the, let me complete. I'll give all the possibilities to the guy who designs it. For example, I want the data. Suppose Dr. Sidhu told, he told data must come wirelessly, okay? Then we have lot of LoRa I want to put. Even especially for the tracker also, I was actually thinking LoRa is the best. Actually, my dream to have in India for agriculture, a wireless network free must come to the farmer. You think about a farmer has one seeder which works only for 1 month in the year. You can put a GSM card for that 1 month for that? He will not afford. He has got a pump somewhere running, turn on. He'll put a GSM? No. So when you see a farmer, it's not like a car you are having. It's not like a cell phone. A farmer has so many devices. So many devices he has got. So for that, one of the technology, we'll discuss in one of the technologies also, what I propose. So this all you must know. If you don't know, he will come with a GSM chip solution and he will end up 25 SIM card in one form. And the fellow will not pay the bills. So, next question, anybody has? I think nobody I see.
Dr. Syed.
Yeah, please.
I think it was really, today very well, very good, acceptable speed and explanation. And I think I'm expecting people will come up with, some questions, because what are the expectations that what actually has been done on visa field, and you are trying to explain and what actually expected from agriculture engineers. I just wanted to know, because you are saying three aspects, that is hardware, embedded system, and internet domain. So all three, for an agriculture engineer, which one he should specialize one, or which should he prefer, or all three can be how one person can expertise in all three, and to what extent?
Okay, you're asking a very interesting question to an agriculture engineer who is already learned a lot of other subjects. Okay, mechanical engineer learns only mechanical. Mechanical engineer he also does not learn electronics. He does not learn civil engineering. Whereas agriculture engineer, no, what we require, how agriculture engineers, agriculture engineers, for example, they are not very good in designing dams. I don't think so. I would ask one small question, very small question. You ask interesting. I'll ask a question to you. Now we have COVID problem, and everybody is talking about what do they call the breathing? You require ventilator. Okay.
Yeah.
How many agri engineers thinks you can design a ventilator? It's an excellent question. I thought about it. Okay. Yeah. I can design.
Yes.
So why I'm saying, why you are not confident you can design? I'm sure you can design. Why you are not confident? Because ventilator means they show you a graphic screen with something moving there, some high-tech buttons, whatever it is. Oh, this I don't know. I don't know how it works. Okay, it's electronic. I explain you what is ventilator. There are two valves, pressure valves required, pressure measurement. Okay, one is a air coming inside, okay, air or oxygen, whatever they put. Okay, and that can go through humidifier, whatever. That all very easy. Then another going out. So we measure the pressure of them, and only you have to control by timer pressures. There are 7 types of doctors use the system of giving for the patient. Either constant pressure you want to give, or you want to give constant volume you want to give. There are different, but these are all only operating based on 2 of the pressure valves. Okay, you turn on the oxygen and the air mixture, whatever required, for a particular time. That is all principle. So I want this, like this, agriculture engineer to understand what I say in all the 3 parts. I want them to know embedded little bit, starting with, especially middle management and the top management must understand possibilities. If I go and ask top management, for example, the tracker ka, what type of communication will come? Okay, he's worried about money also, he'll ask for communication. So he must know about communication features, building blocks. If he knows the name, he can read in internet also. because he will not be, I don't expect them to go to the class and study. There's no use actually. That is not the aim. Middle management must know implementation also. Implementation, for example, web server, the data to come, what type of feasibility available, how much cost will come, which is better for agriculture purpose. Down level, he must know something board goes wrong. He must be able to repair himself. Okay. In the farm, we expect a farmer to go and change the fuse, whereas agriculture engineers cannot change the fuse. I think we change. So I think B level, they must have some small idea of soldering and this thing. Some small example. What I'm asking is not so complex. Programming, they're already studying Java, everything. Okay. I saw 15 years back computer screen. I want them to learn C program embedded. Just a little bit example. Turn on a pump, turn off the pump. Okay. With that, if they learn, big programs they need not write, but they can understand.
Thank you.
I think yeah, please. One more speaker is there.
Opening for questions. People must ask questions so that you can clarify and people should understand. So please ask questions, my dear young friends.
Before I come to Dr. Singh, I want to ask Vishram Pai. Can you enable him voice, please? One of the attendees. Vishram Pai, you can talk. Vishram Pai, you're still there? You have to enable your mic. Okay, he's not there. Next one, Gauripati Rao. Can you enable Gauripati Rao, please? And disable Vishram Pai.
Hello.
Yeah.
Yeah, good evening, sir. Sir, can you take any simple example regarding temperature and can explain on the coding, how it is being done, how the technology simulation and all that, so that we can get more clarity on that? Because I am an agriculture engineer and I've done PhD in mechanical engineering. So I worked on MATLAB programming and all that system and how to design the farm machinery through the software. So it will be more add-on if you take some syntax, only one temperature parameter or one moisture, and how to code on and how this PCB is designed using this as a parameter.
Thank you.
How to come up with it.
You're advanced stage actually compared to other viewers I'm seeing. So in this particular 3 days we have session, it may not be possible, but we will 100% take it up afterwards. We'll take, because 3 days session only we have, 30th we are closing. In this series only is the introduction, all the features we are telling. Now, for example, you know where to contact. We will contact for you specification. Thank you. Next one more, Bhaskar Gaikwad. Can you enable?
Hello.
Yeah, please.
Am I audible, sir? Yes, sir. I do see that in the IoT system, the ultrasonic sensor likely is SR04. We tried that sensor as well, and for the only issue we faced was in a relatively high moisture content environments, the transmitter receiver plate starts corroding because we cannot shield it.
No. Come to the point. Tell me exactly.
So the point is, have you experienced any questions?
Wait. No, I'll ask a question. High moisture means what you did? You didn't.
With 100% relative humidity.
No, but you enclose with a IP65 enclosure or not?
No, that is okay. But the transmitter and receiver plate cannot be enclosed.
Which, for soil moisture measuring?
No, for ultrasonic depth measurement.
Ultrasonic, but why it has to be far away in the field? What application is where you can use? You have to find the correct sensor. This particular, you cannot have 100% moisture. 99% will work also. In rainy season, it will work. Okay, if you put on a water tank 1 meter high, it will work. But be careful about temperature compensation you must do in ultrasonic, because winter you measure, summer you measure, there will be difference in variation, because ultrasonic is responsible for a temperature variation. If you do that, then problem will not be there.
Yeah, okay. Our issue was accumulation of moisture on the transmitter and receiver plates.
Then use another expensive sensors available. What I'm asking is, the world is full of options. You pay vada pav, you pay 25 rupees, you get vada pav. Okay, if you want say higher, you get higher one. Next, okay, I think questions are over. I would anybody wants, you can ask me questions. You can raise your hand. From the attendees, I was seeing first. I'm interested more in attendees. Anybody speaks, or Dr. Indramani, if some questions are there through Facebook or something like that, you can get from them and you can interrupt me and you can ask. In the meantime, I would ask. In the meantime, you are collecting. I would ask Dr. Professor Gajan Singh
Yes, thank you, Syed, for excellent presentation, though I did not understand most of it, but I was trying to catch something. My feeling is that I think people like IRI, CIA, and agriculture engineering colleges and departments actually have to build a team. Maybe it's not easy for one person to learn all those things, but we have the new recruits, young scientists, huh? And if we based on their interest, because I think this area of developing sensors and with Wi-Fi systems and all that, I think we need to create teams.
Yes.
And I think Syed, you can play a very good role in encouraging these teams to be cohesive and work together. So I think it has to be a teamwork. It cannot be left to the individuals. And if there is a significant number, 4 or 5 people together, I think we can make an impact.
Yes, I agree with you, Dr. Singh. Actually, before 6 months, I sent this proposal for training to 2 of the colleges. So I sent about 9 days of the program required, 7 days, 8 days program, 8 to 9 hours participants, 20 students I will take and train. But ultimately, when I contacted the deans back, I think the colleges are more interested in different activities. They are not bothered much because neither the deans, I don't want to say which universities or other people, none of them know about electronics. They say it's not our job. Electronics people are different. So that has to change. Actually, the middle level, top level management has to accept to allow this to come. But I think because of the only started, IRI offered. I know that you offered me, but unfortunately, but I think we should start somewhere, not blame others. Whatever, they'll come and join the group. I think one team has to be formed. I think Dr. Indramani is very.
Well, IRI is an excellent place, and CIA and IRI are together in offering the master's and PhD program. And there are so many topics coming out, excellent research topics for MTech, working on the sensors and so many different aspects. I think even evaluating those things, the sensors, how good they are, in what conditions they work, and then come out with alternatives, that will go a long way.
Dr. Murthy?
Yes. So, Dr. Ismail, thank you so much again. So, I had one very, very specific question actually. So, you showed that you made your own custom PCBs. So, how difficult was it for you to actually get them printed and mass manufacture it?
Okay.
Thank you.
The PCB design we do, and we say it's called the computer. We generate Gerber file, GERBER. It's called. I just click here and send it the file. Actually, I get the PCBs done from one of the companies in Ahmedabad, near Ahmedabad. They're very good, high quality. Delhi is excellent quality available. Bangalore available. It's online, nothing else. I just click there, and because I'm a very old customer, I do not pay for credit card. Okay, they send me a bill. Okay, so you can get the PCBs in 5 days, 3 days option, 5 days option. But I think 15 days is probably you get reasonable pricing. But volume production, you must look for 1 month. So nothing you have to do. You'll reach your office, you come there. Now, manufacturing is another. First day I showed you the slides. Manufacturing, you require a pick place or you put a stencil. I will show again the slides, and you need a oven. Okay, very small oven you can have for lab. I showed you this all. So we'll see that again. That if you have, you can make yourself. Okay. You can also these boards are hand soldered, not even oven soldered. What you saw that. Okay. Anyone technician you have who can solder it, hand soldering one person is enough for you. Thank you. Next, anybody has questions? I want suggestions again because I don't want to start the topic of training again. Now, from you, somebody told me about yesterday. I went very fast, so I will go back to those slides and again refresh. In between question is there. You can ask. Now, can you put the presentation please for me? Setu, yesterday's presentation you have? I have, sorry. Just a second. Setu, you have the presentation? Next one. Next one, please. Okay. No. Back. One back. Back. Oh, thank you. So here, this I think people didn't understand yesterday. Afterwards, I talked to several people to select a controller system. Today, we saw one of the microcontroller I showed you. Important features are how much memory it has got. How much data logging means EEPROM, electrically erasable, programmable, only memory. You need not worry about details. This talks about memory part of it. This talks about analog, where we use analog. For example, capacity measurements we can use analog, or we can use even digital. Then you have URT, moisture sensor. For example, this moisture sensor uses URT. This use, for example, 1200 baud rate, even parity. What this, or SDI 12 protocol. These two can be used with this. Then you have I2C. We already saw example I2C. This is a local communication via protocol, local communication. I2C and SPI. I2C, we saw already example today, I showed you. But if you forget, don't worry about it. CAN bus will come and one day talk about protocols. USB, we all know, just to connect and download, we know it. Then about timers, we talked about it. Real-time clock, we talked about it. Watchdog, the importance of watchdog. So these are all for management tool. You know, when a design comes, I have watchdog in this, what I gave it to this. So it will not hang. It will not hang. If anything goes wrong also, it will automatically break by itself. So that is important feature we will tell. Because this electronic fellow will not know watchdog has to be enabled separately done. IRC, somebody asked me a question yesterday. This is actually internal RC oscillator, which means a crystal is not required. A crystal attached to crystal attachment is more expensive, that's all. But when you want to use high-speed transmission, time-based, accuracy required, then you have this crystal. Temperature variation also you must see. For example, I'm using 1%, this controller what we'll use is 1% is the accuracy of the frequency. So when you go to that 1%, is tolerable when you transmit. But more than that, you cannot. Then you have to use crystal. Certain communication, for example, I also make systems for ATM rooms, machines, everything. They require a high accuracy, so I use a crystal. Then you have the input-output. These are possibilities. We talked about PWM, pulse width. Every controller has it. Just we introduce that terminology to you. We don't use PWM in this case. In BISA case, we don't use it. And this is the microcontroller what I talked about. Next slide, please. Say to next one, please. Next one. This is the Arduino, which I told really low cost. Now, if you ask me why I didn't use Arduino for this particular application, because it's very small, we cannot use it. It doesn't have the Wi-Fi connectivity. It will be very expensive to use, and this is very speed also very less. Next one, please. I will take just 2 minutes. I'll close it. Next one. I will just. Next one. Next one. Yes. This is a chip what we used in what application we saw it. It has got a Wi-Fi antenna. So backup and power down. Power down is important now because we use battery. So what it does is he sends the data, then he sleeps automatically. He will go to sleep, power down more. How he wakes up? He will automatically wake up. Okay, now we don't have somebody to wake him up. So he'll wake up. That's a timer, watchdog timer. Separate timer is there. That will wake up the system again to come. And this particular system on chip is not very good in power down mode. There are other things are available. Which are which is efficient, will not consume that much power. You see, the power is required for transmission data. This is a Wi-Fi transmits long distance data. So the data transmission only consumes a lot of power. But this, particularly this system on chip, basically consumes more power than other available systems. So, but why we chose this? Because price-wise attractive, and plus it is enough for this particular purpose. So this is how you have to select, and I think I'll stop with this unless something is, I don't see any questions out there. I think we take it a call. I'd like to close. Dr. Indramani, please make a closing remarks, please.
Thank you, Dr. Syed. First of all, I would like to thank Dr. Sidhu, for not only for this presentation, but for, a very, wonderful and excellent work. It has given a lot of, name and fame to the profession, because visa is being managed in the whole engineering aspect is being managed by agriculture engineers. So thank you, Dr. Sidhu, for doing wonderful work. And this is what we are expecting, that how we can connect other agriculture engineering institutions which are engaged in research to visa with your program to some extent. Am I audible or not?
Yes.
Yeah, very much audible. I see Dr. Professor V.K. Tiwari also there. I think Rauri. I think you remember Rauri. I think he was very. One more person. I would like to mention Dr. Tiwari. We used to have in Rauri we met in Pune last year.
Yeah.
We used to have very tough discussion. He also one of the guy wanted changes. Actually, sorry, V.K. Tiwari wants a change, drastic change, and now he's.
V.K. Tiwari will be our chief speaker on last day, 30th. He has agreed.
Speaker, okay, but then he has to do something. Now we are there, so we will do.
He will basically.
He and Sidhu, very dynamic people. I mean, I really appreciate V.K. Tiwari. Very nice. Happy that you are there in this. Thank you.
Yesterday also you are there. Thank you, Dr. V.K. Tiwari sahab. And Dr. Syed, you have basically connected very well what has been done at visa, and then how it can be made understandable by the people, and then the rest of the program. I think we are on the right path with the blessing of Professor Singh and all our senior people. I think we'll have based on these sessions, we will select few people who have who have developed their understanding about electronics, and we will run with the ISA, and with your help we will run level 2. This was level 1. We will go for level 2 training, where what's processing we are expecting that at least
He's having voice problem. You are hearing me?
Yeah, Indravani need his bandwidth to be improved.
Yeah, maybe that's. Anyway, I think I will take this opportunity now to conclude. Dr. Singh, Gajan Singh, you want to say a concluding remark?
I think we should conclude.
Okay. I think I thank all the panelists also, and thank you very much. I think Tiwari can do, and Dr. Singh is all the time with us support. I think we will do something what I dreamt always. Like it's my duty to give back what I learned from others. And from Dr. Singh has given me the freedom. I remember I was doing solar energy and a project in second term, and for third term I went to him. Fourth term I went to him and I want to change my project to electronic control system. He told 2 weeks you go there, pass the test, then I will take you. And that changed my life. Thank you for that. And I think I want to give back to the society same thing. Thank you very much for coming. Tomorrow we'll have an interesting session again. Thank you.
Thank you very much.
Thank you. Thank you, sir. Everybody. Thank you.
Thank you, everyone.
Thank you.
Variji.
Namaskar, sir. Namaskar.
Thank you, sir. Thank you.
Jetu?